Welcome to Cosmic Compass, where we explore the stories of space, the planets, and the forces that shape our universe. Today, we're diving into one of the most daring experiments ever attempted, NASA's DART mission, a real test of whether humanity can defend itself from the dangers of space. Together, let's uncover how a refrigerator-sized spacecraft changed the orbit of an asteroid millions of kilometers away, and why this marks a turning point in planetary defense. Imagine waking up one day to the news that a massive asteroid is on a collision course with Earth. What would we do? Could we change its path? Humanity has long looked to the skies with awe, but also with a lingering fear, the possibility that one of those countless rocks could one day end life as we know it. This isn't just science fiction. 65 million years ago, a space rock struck Earth with devastating force, ending the reign of the dinosaurs. And today, the same universe that gives us breathtaking night skies still hides threats that could alter our history in an instant. So how do we protect ourselves? That's where NASA's DART mission comes, in a bold first step in defending our planet. Almost 1 year before the historic test, NASA launched DART, the Double Asteroid Redirection Test. Its goal was simple but groundbreaking: to crash into a small asteroid and see if the impact could shift its orbit. The concept behind this is known as kinetic impact. By slamming a spacecraft into a near-Earth object, or NEO, we could nudge it ever so slightly. That nudge might not seem like much, but over years or decades, even a tiny change in trajectory could mean the difference between Earth's survival and catastrophe. Dimorphos, the asteroid chosen for this test, was never a danger to us. But the lessons learned from DART could one day save billions of lives. It was in essence humanity's first rehearsal for planetary defense. The target was unusual. Dimorphos is not a lone wanderer, but the smaller half of a binary asteroid system. It's a moonlet just 160 meters across, orbiting the larger Dimorphos, which measures about 780 meters. Together, this pair travels around the Sun once every 2.1 years. Dimorphos itself completes one lap around Dimorphos in just under 12 hours. This made it the perfect candidate, small enough to be shifted, but large enough to teach us something meaningful. In October 2022, the Dimorphos system came within 10.6 million kilometers of Earth, its closest approach since 2003. That proximity gave us the perfect opportunity to attempt something no one had ever tried before. DART itself wasn't a giant spacecraft. In fact, it was about the size of a refrigerator and weighed just 610 kilograms. Compared to Dimorphos, with an estimated mass of 5 billion kilograms, DART was a pebble against a mountain. Its primary payload was a single instrument, the Draco camera, short for Didymos reconnaissance, and asteroid camera for optical navigation. Alongside Draco, DART carried an autonomous navigation system designed to guide it precisely into its target. But DART did not travel alone. Riding along was LICIACube, a small CubeSat built by the Italian Space Agency. 15 days before impact, LICIACube separated from DART and prepared to document the aftermath of the collision. Equipped with 2 cameras, playfully named Luke and Leia, it was ready to capture history in the making. After blasting off aboard a SpaceX Falcon 9 in November 2021, DART spent 10 months quietly traversing space. But in the final hours before impact, things became dramatic. 4 hours before collision, DART's navigation system took full control. At 24,000 kilometers away, Dimorphos appeared as just a faint dot no larger than a pixel on Draco's camera. As the minutes passed, that dot grew, filling the screen with greater detail. The spacecraft hurtled forward at 22,000 kilometers per hour. Just 3 seconds before impact, Draco revealed Dimorphos's surface as a chaotic pile of rubble, a loose collection of rocks left over from the solar system's birth. Then at 6.6 kilometers per second, DART struck. Its signal cut off mid-image. leaving behind a final fragmented glimpse of the asteroid's surface. After travelling 17 million kilometres, its mission ended in a blink. Think about that for a moment. We were watching in real time a human-built machine end its life by crashing into a world millions of kilometres away, and doing so with absolute precision. Now the question, did it work? NASA had defined success as shortening Dimorphos' orbital period around Didymos by at least 73 seconds. Any more than that would be considered an outstanding achievement. The results shocked even the scientists. Observations showed that the orbital period had been reduced not by seconds, but by 32 minutes, from 11 hours and 55 minutes down to 11 hours and 23 minutes. That is 25 times more effective than expected. The impact released 19 gigajoules of energy, the equivalent of nearly 5 tons of TNT. It blasted a crater up to 150 metres wide, nearly the size of Dimorphos itself. For the first time in history, humanity had changed the orbit of a celestial body. Of course, we couldn't rely only on DART's onboard instruments. Telescopes on Earth, such as the Southern Astrophysical Research Telescope in Chile, tracked the event. By watching the light curve of the Didymos system, the way its brightness fluctuates as Dimorphos moves in front of or behind its parent asteroid, astronomers were able to calculate the new orbital speed. SOAR even captured breathtaking images, a tail of debris stretching 10,000 kilometres, making Dimorphos resemble a newborn comet. For a moonlet once invisible to the naked eye, it had suddenly become a spectacle. Meanwhile, LICIACube performed its own daring flyby. Just minutes after DART's impact, it swept past Dimorphos, photographing enormous plumes of debris billowing outward. Some appeared to spiral like tendrils twisting in space. This suggested that the asteroid's loose rubble pile structure had scattered material in unexpected ways. And LICIACube wasn't alone. Both the Hubble Space Telescope and the James Webb Space Telescope turned their gaze toward Dimorphos. Hubble captured dramatic rays of debris, some oddly curved, a mystery scientists have yet to explain. Webb, observing in infrared, recorded the moment of impact and the 5 hours that followed. It was able to track Dimorphos moving 3 times faster than Webb was designed to follow, a testament to both the spacecraft and the ingenuity of those who operate it. Together, these eyes on Earth and in orbit gave us a multi-dimensional view of one of humanity's most audacious experiments. But DART was only the first act. To truly understand what happened, we need to study the aftermath up close. That's where Hera comes in. The European Space Agency plans to launch Hera in 2024. Arriving years later, it will map the crater in exquisite detail, study the asteroid's shape and composition, and even investigate Dimorphos' subsurface structure. Accompanied by 2 nanosatellites, Milani and ESA Hera will turn the Didymos system into one of the most studied asteroid pairs in the solar system. Its findings will refine our understanding of how momentum transfers during an impact, and how future missions can be even more precise in deflecting potential threats. So, what does this all mean? For the first time, humanity has demonstrated that we can change the orbit of another world. Dimorphos was never a danger to us, but the technology and lessons from DART could one day prevent a catastrophe. We've barely scratched the surface of planetary defense, yet this mission has proven that the idea works. It is no longer just theory. The next time you look up at the night sky, remember this: among those countless points of light, there may be one headed our way. And thanks to DART, we now know that we are not helpless. We've taken a bold first step toward protecting our future. But what do you think? Will humanity ever need to use this technology for real within our lifetimes, or will DART remain a historic test, a proof of concept never put into action? Either way, this was more than a spacecraft crashing into a rock. It was a message to the universe: we are learning to defend our home. That's the story of DART, the mission that turned science fiction into science fact. For the first time, humanity has proven that we can reach out and reshape the cosmos, even if just a little, and this is only the beginning. If you enjoyed this journey through space, don't forget to subscribe to Cosmic Compass for more stories of our universe. Together, let's keep exploring, keep asking questions, and keep looking up, because the cosmos is vast, and we've only just begun to chart its map.